changing gears and looking at dikes and dike swarms. So basically, the paper published on dikes and dike swarms is called Formation, Erosion and Exposure of Early Amazonian Dikes and Dike Swarms and Possible Subglacial Eruptions in the Elysian Rise, which will be a basin Mars. And again, highlighting what is important from this article, we see new observations of dikes and dike swarms. We report on the first exposed dike swarms on Mars. And we see some evidence of subglacial emplacement and possible subglacial eruptions. And this has implications for the volcanic evolution of the Elysian volcanic province. It also has implications of the erosion rates in the area, because it's not very normal to get exposed dikes, because the erosion rates generally are pretty low in the region. And then we suggest some volcano-ice interactions. So just to refresh, this is a volcanic plumbing system over here, and dikes are generally vertical intrusions, as you can see them here in orange. And dike swarms is just lots of dikes. And not all dikes erupt. So this is what a dike system can look like. This is from Chick Rock, New Mexico. And what you see here, the linear features here are dikes, and this is the volcanic neck. So a former volcano which has been eroded down. And here you can see a Google Earth image. It's approximately 6 kilometers wide this way, showing the dikes here. So the morphology of exposed dikes is generally linear ridges, uniform height and width of the ridges, parallel orientation or radial in the case of this kind of feature. The ridge is usually cross-cut other units and can be emplaced en echelon. Moreover, there are some morphologic characteristics for dikes that are not exposed, and that sounds maybe a bit weird. But if you just look at these images, which was taken on Hawaii here this March, you can see that just close to the fissure eruptions, you have a lot of fracturing in the area. And this has been explained by several authors, and one of them is Ernst et al. 2001, showing that when you have dike emplacement in the subsurface, so you are intruding a body of magma, just above the body of magma, you get extension. So you have extensional forces, which is creating a graben-like structure. You can also create cracks, and you can also create something like pits. Moreover, Robin and Pollitt have monitored this with their geodetic data. Here is from Iceland, and this is from afar. And what it shows is the changes of the elevation after a dike intrusion. And what you see here is that you have the dike intrusion down here, and just around the dike intrusion you have an uplift, and immediately over the dike you get an extension and a fracture of the So basically, dikes that are not exposed can also have these indicative morphologies. So previous studies on dikes have been performed here in the Hellersrud et al. 2010, and some big dike swarms have been reported based on graben studies in the region of Tharsis over here. Looking at my study area, no exposed dikes or dike swarms have been found so far. However, a lot of activity related to volcanism has been found, which is pretty obvious. We're just close to a volcano. So this is just an image showing some suggested lahar deposits by Russell and Head 2003. And these deposits have been suggested by several others, Christensen and Greeley in 1981. Yeah. Other studies related to dike activity is by Chapman 2003 and 94, suggesting hyloclastite ridges or Mørbæk ridges, which is basically dikes emplaced in ice. You see them a lot in Iceland. So dike-related activity has been seen before in this region. So just to show you again what we're talking about, here you have the entire geomorphological map, and what we are concentrating on now are the red lines here, which are all the linear ridges found in the region, and also the fractures here in orange. And basically what you can see is that they have this northwest-southeast trend, more or less the same orientation, all of them. So the simple ridges look like this, and this is a ridge here and here. Generally, the simple ridges are linear with little or no curvature, have uniform width and height, is in place en echelon, is associated with fractures and edifices such as these Møbak ridges that I just showed you before, and they're cross-cutting different units. The multiple ridges and interpreted dike swamp systems are these ones looking like this. So they have this wedge shape, they have a braided appearance, they're associated with stubby flows. This is just a ridge where you can see some stubby flows from it, and they're cross-cutting different units. So what we suggest is that these ridges are of early Amazonian age, and we do this based on this kind of cross-cutting stratigraphic relationships. What we see over here is what we interpreted as the dikes. We suggest to have intruded this flow here, creating these fractures along the side and producing these irregular hills. So they are basically cutting at early Amazonian outflow deposits. And the other image here is showing an outflow channel highlighted here, which seems to have been constrained by the existing ridges in the region because it has such a funny shape here. Maybe it's a bit easier to see on this newer map here. This is the same outflow channel, and in red you can see how it's constraining the shape of the outflow channel. So we suppose that these ridges are of early Amazonian age, and that's basically just a period in geologic time on Mars. We usually see the dikes exposed in an uppy texture unit, where we have this kind of inverted crater morphology that I told you about earlier on. So that suggests some kind of possible wind erosion. And moreover, we see these ridges associated with these stubby flows, the suggested Møbak ridges, and some irregular hills, as well as some cauldron-like features or depressions like this one. Here you can see the ridges here and here, the cauldron-like features here, here, and here, which is similar to what you see when you have subglacial eruptions on Iceland. So, we see hundreds of these narrow ridges. They are linear, uniform width and height. They are amish along the place and is associated to fractures and different kind of edifices, which exclude landforms like eskers, inverted stream channels or faults, and therefore we suggest that they are dikes and dike swamps. Moreover, I just said this, they are associated with ice cauldron-like features, stubby flows, and suggested Møbak ridges, which suggests that some of them might have intruded ice-rich deposits. They have this unidirectional orientation, northwest-southeast, suggested that they have been governed by regional stress. The braided dikes suggest that we have repeated excavations of the same dikes over a short time, and then we see evidence of dike-induced dilatation and some significant erosion in the area since we have the exposed dikes. Okay.